This time on Captain Castle's Laboratory, we're going to be working on some Lemax trains. So this is similar to the trolley that they have that goes back and forth using magnets at either end of the track. This one can be a little bit longer. There's an extra piece. And how this train works is this rubber and this rubber stopper tell the train's directions by flipping this lever back and forth. You can see it changes. So there's two trains here. We got a silver engine and a black engine. Silver engine does work. Black engine, the little switch doesn't move. It's stuck. I can turn this side freely. This side doesn't move at all, and this doesn't move. So something inside here probably broke. But this is a 4.5 volt track. I'm going to slide it over. And here's the controller. Plug goes in here. And on off right here. And speed control. This is your knob. Now it's a 4.5 volt track. Remember that. Because this train does work, but it doesn't move very fast. So I decided to pre-test them before anything. So as you can see, right now we have almost no voltage. So I'm going to turn it on. So there's, it's got bleed through voltage. I got 5.48 volts. So I'm going to turn it off and we're going to set the train on. The problem is that voltage keeps changing. So 1 minute it has power and the next minute it doesn't. So let's get this thing on the track because the tracks are energized, unlike the trolley which runs on batteries. I'll turn it back on. The train's not moving. Now, if we go back and touch the tracks, 1.3 volts. What happened? So, let me see if I can just kind of hold these here while I take the train off the track. So, most likely what's happening is something in here is doing an excess draw. But before I turn on the camera, I did test this track at full power on this knob, and at full power I was only getting 1.5 volts, which indicates to me there's also a potential problem with this knob right here, the speed knob. So right now it's pegged, which means this thing should be going voot, 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 and we're good to go, but it's not moving. So we're going to plug this into my machine, and this machine will tell me if there's a short or if an excess draw. This is your power, these wheels right here. So if I turn this back on and just touch the front wheels, it's supposed to have these trucks turn, and it does intermittently. So I was trying to figure out why I had it, because it was working just fine for a few moments. So, but there's nothing there. So this track is positive, this track is negative, just so you know. So the easy way to remember is if you have this piece, I'm going to unplug this one. Play train in this direction. So the arrow, there's one on the other end too, is on the positive track. Easiest way to remember. Plug it back in. So I'm not going to have it at full 4 volts or 4.5 volts. I'm going to drop it down to 3. And I'm going to clamp this wheel, which would be the negative. It is pulling 1.5 amps. That is higher than that thing can put out, the power supply. The factory one from Lemax. The factory one from Lemax is set for 700 milliamps. I'm pulling out 1.5. That is literally double. It's actually pulling out 1.4 and is bouncing between 1.39 and 1.44. So it is pulling double the power that AC adapter that's plugged in right here can do, which indicates that there's a problem with this train. Now we're going to do the same thing with this one, which doesn't work at all, and we're going to see if this one does the same thing at 3 volts. So, clamp it onto the front truck and power back on, 3 volts. Oh no. And that wheel just came off. And this one at 3 volts is pulling 0.3 amps. But I still can't change directions. So, what it's supposed to do is switch when I change it, but it's not switching. So they both have an issue. I wonder how much it draws at closer to its full power, which is 4.5. Oops, a little too high. Back on negative. .4 amps. And there's your light. Yeah, the email said that one of the wheels kept falling off, and I'm assuming it's this train, because there's another train he sent too. This is just, these two are the same train. Different models, but they're the same train, they're on the same track. Also, if you notice all these little, you probably can't see right, oh, just use a piece of track here. You can see them perfectly. All these little holes, and you can move this rubber stopper up and down the track so it doesn't impact the ends of the track itself. Alright, so I'm going to go ahead and remove this from my work area. So, yeah, we're going to move this. As well. So now we're going to deal with the trains. Since the black one has the wheel that's falling off, we'll start with the black one. Looks like there's 4 screws that hold it together. 1, 2, 3, and 4. What I want to do on this one real quick is make sure we have motion on the hydraulic. We do not. So when the train spins, you can see this bar goes in and out. Just how that just snaps on. This bar doesn't move at all. It's stuck inside. Probably because it got glued in. So this is just held on. It's just clipped on the whole front. So you can change the LED, which is nice. The cover right here unglues, so you'd have to heat it up or pop it off. And then there's a little clip on the bottom, which is apparently worn out because it's loose, but it's plastic. The body of the train is plastic, but this part here feels like cast metal, like a Hot Wheels or a Matchbox car, like that zinc. Which it probably is, so that it could screw in the bottom and handle the torque of the moving components. Oh. One thing I did do to the silver train while I'm taking this apart was these rear wheels were almost falling off. The screw had come loose, so I screwed them back on so I could test the trains real quick. So I can get an idea what's going on. I have an email with the info, but it's been a while, so there we go. So here's our internals. So this is actually plastic. The reason it sounds metallic, there's a big weight right there. Look at that big heavy weight. And then we have another another weight right here. They're both metal, they're magnetic. Here's our motor. It's an F-series motor is what they call it. And I'm assuming it looks like it's direct drive. Well, kind of. There is one gear in the middle. It looks like there's a screw here and a screw here to get to the gearbox. We know this one works as far as motion. What we have is a bad truck, a stuck ram, which of course is just fake, and loose set of rear wheels. So these rear trucks should pivot and move, but if they're too loose, I'm just going to tighten it without using the screw electric part. This screw, if it hangs down too far, will catch those rubber mats and then it doesn't reverse. Oh yeah, we also probably need to open up the gearbox to see why this doesn't pivot. Yeah, it goes into the gearbox. Alright, so let's completely dissect this guy. So our little hydraulic canisters are held on with screws, one on each side, which I don't see any reason to pull those off, truthfully. But we're going to unscrew the little gearbox. But hey, if you got this and you want to repaint it, you can disassemble every piece of it and modify it. In case you're not buying it for the Christmas season, you're buying it for something else. There we go. So it's got two little drive gears. And what does this flip? So this whole base slides. Let's quickly check the drive gears. They look okay. I don't see any damage to the posts that hold the gears. I'll show you how this reverses and how it works. Let me get these two gears into their gearbox and I'll explain the process. First we'll get that one in, and then we'll get that one in. It's a very simple process. And it's very similar to how reverse would work in a manual transmission. Old style, not new. Although they're pretty close to the same. So we have two gears. One's being driven by the motor, so the motor is always spinning in one direction. And when I spin this one to the right, that one spins to the left. Motor's not reversing polarity, so what this is attached. Just on this pin. Imagine it upside down. So the motor is turning this outer gear. And then the outer gear is turning that little gear right there. And when that motor is spinning in one direction, it turns. When you flip this switch, you see how the gear is trying to move? The gear goes from sitting on top of one to sitting on top of the other, which is going the other direction. And that's how it changes from forward to reverse. Very simplistic, kind of a old style way of doing it. It's mechanical shifting versus electronic shifting, like on the trolleys. The trolleys that use the magnets. I have one. It's in my Halloween display. It has two magnets with a magnetic reed switch that sends a signal to a little computer chip, which tells it to reverse polarity. So it turns the motor backwards. This motor is always spinning in the same direction, and it's literally just shifting a gear back and forth, back and forth. So it's mechanical versus electric. Mechanical is better because when it fails, you can usually rebuild it. When it's electric, usually the chip fails and, well, you're screwed. So here's the gear that goes back and forth and moves its position. Need a little light. I don't see any damage. I think it's just dry. No lubrication. It's for Lemax, there's not a lot of grease in here. There's usually buttloads of it. So let's drop this back in. Doesn't look like it matters which direction. Let's set her back down. Probably helps if I set it in frontwards and not backwards. So there's a little hole. You can see my hand through it. That hole fits on top of that shift lever. Yeah, she is still not shifting. Shifts without the gear. Doesn't shift with the gear. What is it catching on? I want to say the pin is bent, but it doesn't. It looks like I have full range of motion. Hey, you know what's nice is I have a second one right here. I can check the range of motion. I don't. This one moves a lot more. Yeah, this one has a much larger range of motion than this one. You can see how it moves the trucks. Looks like I need to pop off this middle axle to see what is going on. It's shifting, but it's not shifting far enough. So let's see which side is the release side. Usually one side will slide off the axle and the other side won't. Looks like it's this side that's going to slide off. Yeah, here we go. The reason I need to pull the truck out is the pin that it pivots on is behind it. Gonna remove the floppy wheel. There is a screw down inside here. Okay, all the screw does is remove the cap. It doesn't actually remove the barrel. It's kind of stupid. I was hoping to remove this wheel so I can stop having it get in my way. So the answer to that is negatory. Not happening. Okay. Put it out of the way. So from what I can see, which honestly isn't a whole lot, is either the plastic arm is bent, it's flexing, or it's the pin. I'm probably going to go with more of the plastic arm because there's not a lot of pin showing. There we go. That cap is glued on backwards. So, on this one, I'll use a pointer here. See that hole? Yeah, this one's shiny because this cap goes in the hole, but it's backwards, which reduces the range of motion on the selector. Like I said, I know the person said he tried to fix the train himself and then it just didn't work and he wanted it sent in. And then this one is working intermittently because it's got a massive draw, which is intermittent. So that one's probably just a bad motor. This one is a few other things. The motor's fine. So I mean, I could take the motor and put it in that one. He has one working train, but that's not what we want to do. We want to try and get two working trains because he has two different sets. He just sent me one track to test both trains on, which is totally fine. So we're going to put it together without this cap and make sure it works, and then I'll put the cap back on. Because if this cap is throwing my range of motion off to the point where there's a problem, the cap is either made for that train, which is missing it, or this cap's missing and that cap was put on here because the shape is slightly different because they're two different trains. Now the next problem is, how do we get this unglued? I'm assuming it's super glue. Now this ram is plastic. This bar is metal. So heating up the bar isn't going to hurt it too much, but heating up the plastic, you can distort it, melt it, change the color, so on and so forth. So we got to be very careful. We got a heat gun ready. I'm going to put a tip back on it. So I have the tip off of it for a different project. Set that up here. Make sure everything's moved out of the way. There's the other screw. The next train I work on could be a little bit more difficult. Not this one. Like I said, he sent multiple trains. I'm going to do the holiday train separate from the other train as far as how the videos go. Make sure you keep moving it around. Ooh, I can smell it. It's getting hot. Turn it down a little bit here. Make sure you keep moving it around. There we go. Okay, let's make sure this shuts off. So if you're new, the machine shuts off automatically when it reaches 100 degrees Celsius. That's its cool down. It's at 174, so it should cool down here soon. There we go. So now that it's out, we're going to have to clean out or remount the hole because the residue from the glue is making it really sticky. And if this binds up, it's going to put extra load on the motor, which puts extra load on the track and then extra load on the power supply. So, yeah. All I'm going to do with a drill bit is, if I can find one that's the right size, I'm going to just use it as, if it's slightly smaller, just enough to go in and use the flutes to help sand down the glue residue. But I don't want one that's so small that I make it oval, or one that's too large to fit. So this one's pretty close, but it's still tighter than I'd like. So it's turning because it's catching on the glue residue. So all my other drill bits are smaller and larger. So I'm going to go find a drill bit, and we're going to use a drill bit. I'm going to quickly use it as a reamer. I'll probably take this out to my outside workshop and go through my drill bit kit and find one, and then just so I'm not going to turn the bit, I'm going to slide the bit in and out so that these edges act like little chisels, and chisels off the glue residue, and it's right on the inside of that hole that is catching on. So I'm going to pause this for a moment while I take this out and get it taken care of, and I'll be right back. Alright, we're back. I went ahead and found a proper size bit, and you can see, there we go. So I did put the trucks back on, so in case it did work, I didn't have to unpress it multiple times, or so. But there we go. Other direction. Look at that. Both sides. So it has been reamed out, cleaned out, and works just like it should. So now we're going to go ahead and reassemble this thing, and then we're going to test it out. So, I'm going to slide that in, and I'm going to turn this upside down and hold this in with my finger, because, well, let me show you real quick. I said I would. So here's backwards. If I flip the lever, there's forwards. You see how it moves that gear back and forth? So, and the reason I'm going to turn it partially upside down, I guess, is so I can get this in without those gears falling out like that, because I just lost my grip. So this is going to be the tedious part of the process. So take two. And this time we're not going to drop it. motor in before I screw it down all the way. This So I was rolling the trucks back and forth so I could get the gears to line up and not bind on the motor. It looks like they're lined up, but I'm going to put the screws in part way, and then I'm going to double check it. That way both sides are held, and this way I can do this. You have to use power. It doesn't want to turn because of course you're feeding it backwards through a worm gear, which isn't the best way to do things. I'm not going to go full speed. I'm going to go partial. Now I know that it's seated. Let's screw it down. And one more check. So, there's reverse, and there's forward. Alright, let's finish putting this thing back together again. I did put that piece on before I started the camera just so I wouldn't waste time. Once I pressed the truck in, that way I knew everything was good to go. Kind of fidgety. So make sure this weight is squared. It does rotate, and I think that's part of my problem, is it's rotating. It's supposed to clear this, which is the front truck wiring, and that's what I'm getting caught on, is the wiring. Let's push that back under. It's on the wrong side of the little pin. Let's get you out the front. You out the front. There we go. And let's get a screw in. So that'll hold it for me while we stick the back on. So there's a couple of screws in the back just in case you ever need to remove the roof for some reason, or the top of it, to maybe repaint it or replace it. Yeah, I don't know why you would have to, but I know a lot of rehabs get done on pieces, and Maybe you want to rehab it, and you can actually disassemble some of the body to do individual sections. I've done that on some of my own houses when I've taken them apart to either show you how they work or modify them or fix them. I've repainted sections when they come apart by the section. One of the first ones I ever did was Hideous Harry's Toy Factory, where when it first came out it was the most expensive piece ever, not anymore, and I disassembled it brand new, and over the course of 3 different videos, disassembly, showing you how it works, and then and how to fix it when it breaks, then painting it to make it more Halloweenish, and then reassembly with the new additions like paint job and lights. So sometimes it's nice when they come apart and you can unscrew sections if you want to rehab your piece. Problem is my screwdriver is magnetic, and well, so are the bars, so it tends to want to stick the screw to the bars. There we go. And make sure that it's level and it's set on its pins. So there's only 2 screws in the front of the body and 2 screws in the back, and then it compresses right here at this seam. So I'm checking to make sure it's sitting level, which it is, and I'm going to make sure all the screws are torqued, or tight, I guess. There we go. And now we're going to pop the front on. I might recommend a drop of glue on the front to keep that from popping off. Now, let's bring this back. Put the spare piece of track back. Looks like it should work. Now if you have this train, you would notice that the front 2 sets of these wheels here, these trucks, sit higher. So only these touch because this is your drive. These 2 keep it lined, and these 2 sets are the power. So of the 14 wheels, 4 of them don't touch. Even sitting here, they don't touch. On the track, they don't touch. I've seen a few trains like that where they don't touch. So don't think yours is broken. Alright, she looks like she's on the track. Because I do know, when I was testing it, those front trucks shifted and it arced because they turned. So I want to make sure they're on the track. It's low power, it's not going to hurt you, but it can shorten the lifespan of your power supply. Ooh, that was really fast. I should probably turn that down. Did I knock it off the track? It still has the same problem. It just wants to go in one. Oh, there we go. Yeah. That's what it's supposed to do. So apparently at its lowest setting it can't do it. It's not fast enough. Uh-oh. It knocked itself off the track. You'd think they'd make a little bit better design. hit so hard it jumped the track. There we go. Probably helps if I get it on the track. Let's try that again. I'm not liking how much play they have on these wheels, but I normally do this for about 15 to 30 minutes on each piece I repair. I sit and watch them. I'm not like intently staring at them unless it's something like this where I'm watching the trucks go back and forth. I usually will listen to music or something in the background, which you can't do on YouTube because they'll hit you with copyright. So when I tell you that every piece I repair I run, this is what I do, or I'll move it over and work on the next piece. If it's like a carousel, I'll move it over here or something like that. Ferris wheels are usually too tall to fit underneath the ledge here, so I can't use those. But yeah, this is literally what I do for 15 to 30 minutes to check for problems. So one of the problems is this thing can spin or move way faster than this track is rated. This is about 50% power on the knob over here, right there, and it is smoking fast, as you can tell. I want to see what the draw is. So I'm only putting out 2.5 volts out of the 4.5 it can put out. Oh, okay, let's do this. That way you can see it. There you go. Now, I don't know if this has train cars. This is how it was sent. Same with the one that's right there. If this was just the engine, I would move this back here so it has more distance. I know there's another piece of track, but you're only adding this much to it, and that's not a lot. It'd be really cool if this came with like curves and other stuff, and you can have it like go through your village. It's only 2 feet deep, the entire length of the village. Just have it go around your houses and then back up. I don't think this is compatible with standard HO track, but I'm not into the trains as much as I used to be, so I can't tell you. The trains I do use is going to be one of the next repair videos, which is the ones we're used to with the plastic track. So this is still the same person's train, so he's having a problem with that one too. But I wanted to fix this one first because this one is different. Most people are familiar with the battery ones. This one is actually power from a wall socket. Batteries wouldn't last very long in this. So, for the most part, this one's good to go. I'm going to have to figure out the speed control and figure out why if it hits too hard, it jumps the track. So the shifter works perfectly without this plate. Oh, you can see how it moves the wheels backwards and forwards. This plate makes it only go in one direction. And I'm not talking about the band. But if you notice, because this one's silver and not black like the other one, you know what? I'm going to keep it in the light and zoom in. There we go. Flip it over. So, will it stay? Nope. So if you notice, when it switches directions, it's straight, and then it goes back past the silver. You can see how it's past the silver. Now I'm going to grab the other one and bring it into the camera. And this one's painted black, but there's the same hole. You notice it's past, and then forward, back, forward, back. So I'm not sure if this is the wrong one, or if this only allows it to go in one direction. That. So if the train was just going around a track without these, like if you made a circle, or unless the circle has the power box on it. Let's zoom back out. Wrong way. So I'm going to set that one off to the side. Now this one isn't working at all. And if I remember right, because unfortunately it hasn't been a few minutes, when I went outside to the workbench, my neighbor's like, "Hey, you're outside. Can I borrow you for a minute?" It's turned into much longer, and then now it's the next day. So when you know how to fix things, you get called on a lot. Alright, so this one is showing no draw whatsoever. Yeah, showing 0 volts. So let's open this one now. So I'll remove the track again. We're going to get out of the way. What I am going to do is shorten it, because where I had it sitting, it was a little long and kind of in the way. Try and give you an approximate length. Each one of these track sections is 12 inches, and there's 4 of them, including the end. So that's about 4 feet. It's a pretty long piece of track. Move this over here so I don't lose it. Alright, so let's see what's going on inside the red one. We already know how to take it apart. You have 4 screws on the bottom, and this front end is different. This front end, the whole front doesn't come off. This piece does, just the cattle guard. So, since this is a slightly different train, let's see what the differences are inside. So it's one solid body. It's not a 2-piece. It's still got the same weight and the same weight in the front. So the long weight and the short weight. It is sticky. The light isn't cast into the front. It's just sticking up. I'm also surprised it's not an LED. It's an incandescent bulb. It's one of those little 3-volt ones. Mr. Christmas used them a lot in their carousels. I don't see any broken or burnt wires. I do see rust on the motor. So I don't know if you can see the speckles, like right there. And there's one there, and there's one there. That's rust. I wonder if this got wet. Trucks don't turn because you're trying to drive a worm gear backwards. It doesn't work. So let's take this off so I can isolate the motor from the drive. And there's our T drive. The 2 gears that change the direction of motion. There's our shifter. Just check the main gear real quick, make sure there's no cracks on it. Nah, it looks good. And So these motors work in either direction. So let's see if it works at all. That's telling me it's shorted out. Oh yeah, she's drawing some juice. Actually put it at the max voltage and see what it shows on my machine here. So I put it at 4.5 volts. It dropped it down to 0.8 volts at 5 amps, which is 3 amps over what the machine can put out. So that's a pretty hefty draw. So we have a short. So is it short in the motor, or is it short in the wheels, or is it short in the wiring to the light? Something is shorted out. First thing I'm going to do is I'm just going to inspect the wires for damage, because there is little bends in it from, you know, being assembled. I don't see any shiny wires sticking through. So I'm going to go ahead and desolder one side of the motor and test the motor. So if the motor is separated from two of the wires, because there's 2 wires on each side, so you have 2 hots and 2 nots, you have no circuit, so there should be no short. If you feel more comfortable desoldering both sides, you can do so. Or if you don't have a soldering iron, you can cut them, but then you still have to solder them back on once you reassemble. So soldering works best. So currently on this side is red and green, and on that side is black and green. Now, if you're concerned about polarity, and if you watch previous videos, I either use a red or a black marker, and what I'll do is I'll go, okay, this side's black, so I know the black wire with the green wire is on that side, and if I had the red marker, the first thing I grabbed, I put on this side, say the red wire and the green wire. The green is the light, and because it's an incandescent light, it doesn't care the polarity, meaning it doesn't care which direction it's going. Because an LED is polarized, and it matters which side's hot and which side's not. So we're going to tin the tip and clean it, and we're going to put a little solder in here for conductivity, and then we're going to desolder. I'm going to desolder the red and the green. If I get my fingers on there, there we go. Just like that. So red and green are off. Motor doesn't feel great, doesn't feel horrible. So now we're going to test the motor directly. Turn off the soldering iron for a second. So I got it set for 4.4 volts, just because that's where my finger stopped. Let's see if we get the beeping sound of death. Yep. So it's one of potentially 2 things. Either the motor is shorted, or where they soldered the capacitors to the motor, we have a dead short and no more capacitance, meaning the 2 capacitors have become shorted to the casing, and it's creating a short across hot and negative. So the next thing I'm going to do is let's go ahead and remove the capacitors. And it might be the capacitors, because this one's really shiny and this one's not. Shiny usually indicates excessive heat, and excessive heat can come from a short, so it could be either. So I'm going to go ahead and do the same thing. I'm just going to remove the capacitor from the one side, which again breaks the circuit, and we're going to test it again. So it is a bad motor. So the motor tries to start, and then it trips the machine at 4.5 volts. It is pulling, it's pulling an amperage higher than the machine can read. It spikes up. It will run at 2.5 amps max, and it spikes at 5. So that means the motor is pulling more than 5 amps. Also drops the voltage down really low. So at 4.4 volts, it's dropping it down to 0.2 volts, which means it's a really bad short. So this needs a motor. And I don't know if this motor is stamped, let's take a look. Sometimes they are. This motor has no markings. I believe it's an F-series motor. Ah, motor's full of grease. Yeah, so the lubrication got into it. It's all over the bottom. So a lot of people ask me the motor info, and this motor, well, it does have something stamped on the back plastic. Alright, I can't read it because it's white text on a white background, so we're just going to pencil rub it and I'll be able to tell you what it says. It says Hoipo motor, H-O-I-P-O motor, and then there's a plus and a minus symbol. So this is the minus and that's the plus. So the red was on the negative according to the motor, and the black is on the positive according to the motor. So I do have some motors that are similar size. Let me grab them. We're going to take a look and see if they'll work. I think the shaft might be a hair longer. This one has no markings on the back at all, and no markings on the sides. So how I usually find these motors is just take the measurements of the body and then search for them. So they need the width and the flat and the depth of this nose, the shaft, the voltage. So let's make sure this thing works at the 4.5 volts. So they do make these as a 3 volt. Now at 4.5 volts it's pulling 3.39 amps. This train over here was pulling 0.3, so this is pulling a little bit more power. It also sounds really fast, but there's no load on it. See what else I got? Here's another one. Same, no markings. No, nothing. So it should be the same. This one has a short shaft and a gear already on it. So let's test this guy at 4.5 volts. This one's probably the correct one. Sounds loud, but it's not in here because at 4.5 volts it's pulling 0.19 amps. So it's pulling half of what this one is. So this one's probably a 3 volt motor and I'm overdriving it. Unfortunately, they don't always tell you what the power is when you buy them. The listing might, but if you buy a whole bunch of them and they're just randomly loose in the bag, yeah, it's a hit or miss. Solder this on. We'll swap the gear, and then we'll test it. this gear. Pull off this gear. Pop on the gear. When you push the gear on, make sure it does not touch the nose. This one is barely touching, so I'm just going to move it up a hair, like so. And now, we're going to set this here for the second, because it has a little cradle, and we're going to desolder these capacitors and swap them over real quick. Problem sometimes when you solder multiple things to one point is the first thing you soldered comes off, and that's what just happened here. The first thing I soldered came off. Now it's all together. I'm going to put the gearbox together so I have a load, because it's just free spinning is great, but I need to put a load on it. So the driving mechanism, or all the moving parts, will be my load. I do like their little design here with the mechanical shift, but I wish they made it captive. Be a lot easier to put together. I have to do it like I did before. I'm going to have to set it in there and then feed the motor in, or else the pins are going to shift, and the pin just shifted. No, that one didn't work. So, take your time on this section. Got to make sure those axles stay where they're supposed to be, and that you can get it to line up to the two screws and the alignment studs that are on each side. Now, I'm going to feed this in by lightly lifting the back and then setting it back down. It's not quite lined up, so I'm going to just turn the motor a little bit. So I'm going to turn the power back down. Make sure your screw goes in straight. Didn't at first. Tight. Tight. And there we go. The wheels are turned. Turn that off. So it looks like it was a bad motor for this one. Now we're going to put it back together. So there's a little cavity right here that light fits up in. And since it's flexible, I'm going to put the light in first so it feeds up. Then I'm going to slowly rest this down. And I do like the fact that they don't over-engineer this piece. So the light doesn't have to be captive because it's incandescent. It's just going to glow in its own little housing. And the motor is held in place by that gear holder, which clamps onto that little nose. And then just to make it a little more secure, it has a little pressure from the cab. And then to help hold the wires down and that gearbox, that metal weight. So it's simple and efficient, which is very rare. This is something that you can fix at home without any issues. The little 3-volt light, I found them where like garage sales where people are selling doll houses, because those lights are really common in doll houses. If you have some old pieces, especially Mr. Christmas, you could pull the lights out of that. And then as far as the gears that are in here, you're probably going to find in one of the bigger gear, hobby gear kits. When I say bigger gear, I was going to say bigger gear kit, but that could be mistaken as large gears. But it's also almost the identical gear that they use on a lot of Mr. Christmas carousels and stuff. So it's pretty standard stuff as far as the internals. The motor is also just a generic hobby motor. It's probably a 6-volt motor. They're usually rated like 1 to 3, 3 to 5, or 3 to 6, things of that nature. Because this is a 3-volt based on the amperage it draws. And that was drawing a lot less amperage. Alright, now we'll bring the track back. I don't know if I can, but my bench is long enough if it didn't have stuff on it, but let's see if I can add track. Adding track will do a couple of things. It'll give me more distance between the stops and more resistance, which possibly means less likely to jump the track. There we go. So I have a 3-foot tape measure on the outside of the bench, and then this mat's 3 feet. And if I go from the tape measure on the bench, yeah, this is just under 4 feet long. Now it's just fidgety getting all the wheels on. This one, those front wheels are actually partially touching, a lot closer than this one. This one's at an angle. The front trucks on this one sit lower. Interesting. I wonder which one's newer and which one's older. Alright, let's plug it in and give it a test run. Plugged it in. Yeah, see, it's too fast. Well, if it's too fast, or if you're supposed to secure the track so it doesn't bounce. Bounced off the track again. This one rides a lot better, but still when it hits the rubber stopper, especially in reverse, it lifts the front end up. It actually breaks contact with the track. Let me get a closer look. Yeah. And that's at a quarter speed. That's not even half speed like this one. It's about third. That's half speed and it jumps the track. I can't imagine they would want to make this thing just go so fast. It's supposed to be an ambiance thing, not a race. It's like a drag race. Jumped the track already. Jeez. So at third speed, when it hits the front bumper, which is off camera now because I added the extra track, just to see if it would slow it down, it actually lifts the rear trucks, and in reverse, it lifts the front trucks. Front trucks are your power, so when it jumps the front, you lose the motion. It's an ingenious design, but I think it's in a stupid application. Not on the track. There we go. Now it's on the track. Kinda. For this one to work right, it has to be at just under 50%. We saw how much that one's bouncing. Let's check this one again. Make sure that's on the track. And that one's bouncing about the same, wobble back and forth is what I was looking at. One of the trucks isn't turning. This rear axle isn't turning very well. Might need a little lubrication. Yeah, this one's just proud. These front wheels on this train just sit higher than that train. Even looking at them side by side, you can see that these are higher. That's why these wheels aren't touching. And I don't see any adjustment on... pull them down, but they only go in so far. So I'm gonna ask the owner how they worked as far as what speed they were running the track at, and compare. I'll let you know when I come back. But as far as these two trains go, they're now functional. I'm not super happy with the speed. I think it's too fast. I really do. I'm surprised it doesn't pull the track apart when it hits. I really am. I mean, now on the last run, I was holding the box over on that side, so it would stop slamming into my battery charger on that side, because it moves far enough. But if it doesn't have any cars, because I don't know, because this is all that was sent, I can look it up. I believe it does have cars, since it does have a coupling, both of them. I would move this farther back, and if there was extra track, I would add a lot more track to this. I would also see if they had it where you can just make a circle or a loop, like no circle, not a circle like a round, but with the flat sides. I think it's pretty ingenious how they made it shift gears with this little tab and these rubber stoppers, where that train just goes in a circle or whatever track design you make, as long as it completes a revolution. And the weights make it feel nice and it feels stout. The train, though, has way more speed than it needs. I'm only going 50%. I can't imagine how insanely fast this would go if I go to 100%. And I guess I could try. I'm not going to let the train down. I'm just going to put the front wheels on so I make contact. That might have been too fast. That's crazy, the amount of speed. This one doesn't spin as fast. The original motor, it is spinning really fast. Way faster than this track should ever have. I don't know if you can see the light on my hand, but the lights work fine. The lights are probably voltage controlled, so if I turn the power down... Oh yeah, they get really dim. Look at that. So, anyhow, these are pretty cool little trains. I want to ask the owner about how fast he was driving this, or how fast... I'll see if I can find some videos too online to see how fast this thing is supposed to go, because I am curious. Because this train is bigger and it is slower, which makes sense. This train is smaller and is way faster, but it also has a brand new motor. Motor is a lower resistance, so this motor is a 0.3 and this motor is a 0.17. That's almost half the resistance. Half the resistance means it goes faster. But it's better than the other motor that was pulling 4 plus, because that might be too much for the power supply. The power supply is 700 milliamps and this is only pulling 400 and change, so there's still a buffer, but I'm not taking into account the light and then just the load of it moving back and forth on the track. The more load you put on the car, meaning if you have more train cars behind it, the more track you have changes the load. You could actually exceed the power supply. So you got to be somewhat careful. But I don't know if you can physically tell. So I'll try and line the rear trucks up on the line, like so. And you can physically see, it's not much, but this train is shorter. And this train is narrower, the body. So, and then it's also shorter height-wise. So, bigger train, and put the little train on top. And you can see the stack's taller, and that's taller, and that's taller. So, the black train is slower, and it's probably because it's larger and it's got the original motor. The silver train is smaller and is faster because it has a new motor, which is new as in modern, with a lower resistance. So, just a quick recap in case I don't get a response in a timely manner. To disassemble either one of these trains, and probably other variants of it, there's 4 screws, 1, 2, 3, and 4. Take them out, the body comes off. So on this train it's one solid body, on this train it's 2 pieces. Take the body off and you saw there's just 2 black screws that hold the gearbox down, which is a whopping 3 gears that come out and 1 gear that's captive on the drive axle, and then it also releases the motor. The back of the motor has a flat spot right here. There you go. That sits into a cradle. So the cradle's flat and has 2 curves to help keep the back of the motor from wobbling side to side. And then the front of the motor, where the reversing gears are, where the worm gear goes through, when you screw it down, has a little ridge that grabs this nose right here. So, very simplistic, not overdone. It's not using a motor clamp or a motor bracket. It's literally just 2 screws. And it holds everything together. Like I said, very simplistic, and it's amazing. It's the KISS method. Keep it simple, stupid. Underneath the body, when you take the screws out, there are 4 plastic pins that stick up. Those pins don't go into the body. What they do is they go inside the center of the body. So I'll use the flashlight as an example. So there's no hole for those pins, but the edge of the body, they rest on the inside. So it keeps the body from shifting side to side, especially when you're screwing it. Also, all your wires, the 4, have to be within those 2 pin regions to tell you, hey, this is the outer edges that you can put the wires, so when you screw the body on, you don't crush them and or sever them. The lights, they're incandescents, which is why they have these bulbous lenses. They're rounded, so it gives you that reflective look like on a real train, or like the tip of an LED, so it projects. And they're 3 volt normally, but they can handle up to 6. Some handle 8 or 9, like the Mr. Christmas ones can run between 6 and 9 volts. Now they will run lower, but optimum brightness is between 6 and 9. And you can get them from Mr. Christmas, I believe. He still has some. You can find them online, doll houses, old pieces. If you want, you can change it to an LED. The motor doesn't change directions, which means the polarity is always the same. And the polarity is very easy to remember. If you have the track and you want to change it to a white LED or a gold LED, or if you want to make it Halloween and repaint this and make it a red one or a green one for Christmas, the arrow, hot. No arrow, not. So you just look at the trucks and go, okay, this set here is the hot trucks, so your wire comes up, and this set here is the non-hot trucks, and your wire comes up. Now, you got to also set your LED with a resistor, because most LEDs can't handle above 3 volts unless they're white, and they can handle up to 5 in some cases, and I've seen them a little higher, but 5 is a good average. So a white one would probably be fine. But if you went to a colored one, you'd have to put a little resistor in there, so when you crank this thing up to a higher voltage, you don't burn out the LED. Although, in this case, I can't, because anything above 50%, it jumps the track. So, strange design. So I said to me, it's a design flaw. So, your little rubber stopper, right there, you can see little holes. You could technically take something like a screwdriver, push it out, and move it. So if you want it to go farther or shorter. And if you have a round track, or some sort of loop, and you have a controller that controls the tracks on that loop, get rid of those completely. Just have it go in a straight line, or in a forward direction. Technically, if you had if this was HO, I don't have an HO track or train to compare it to. Jeez. You could modify this to still work on it. You could open this up and have the power go into a track. I mean, anything's modifiable if you try hard enough. But you could make this go in a circle if you had the ability to, meaning the knowledge and the material. But for the most part, if you have one of those small displays, or when I want to say small, that sounds wrong, shallow displays, that's what I should say, where you can't make a loop, because trains have a loop of like 36 inches or 24 inches or 18 inches. That's how tight it can curve before it jumps the track or falls off the track. Because you got to remember, these wheels pivot, these don't. So there's only so much tightness you can put in a curve before you have a problem. So if you don't have enough room, something like this is really good. I don't know if they make the Halloween ones in battery. I think they do. In case you don't want to deal with the electric and deal with it bumping too hard on the stops and bouncing, or having it jump the track and arc, which if you don't catch that can burn out the power supply because there's no fuse. Or somebody screwing with the knob over here and making it go Mach 7 and blow right through this and possibly break the front of the train, since this is plastic. So, pros and cons. But it's a pretty simple repair, whether it's a motor or a gear, relubrication or lighten a lubrication like on that one, where the lubrication got into the bottom of the motor, because that's where the fins are to help it cool. But yeah, as far as it goes, that should do it, but I'm going to double check with the owner, and I will probably let you know when I come back. But in case he doesn't respond in a timely manner, I'll put it in the caption below, or the description, sorry, not caption. But I don't even know what they call this, the holiday electric train set. I'm going to have to do some research. I'll try and find it and label it whatever it's actually called, because I truly don't know. Let me see what it says on the bottom here. Lemax, copyright 19, I think it says 19, yeah, there we go, 1993, Lemax Inc., fabric in China. So it doesn't say the name of the train. And this one says 1990. It might be a 3, but it could be an 8. This one's not as clear. Made in China. So, but anyway, I'm going to try and find the name, put it in the description. That way you can find it in case you have one of these. And then on our next one, we'll work on the battery operated one. Well, the next one I'm going to do will be the battery operated one. Whatever the editor uploads might be completely different, but it will be coming. And it may be in reverse order. Maybe the battery operated one comes first. I don't decide that. I just film them. So, until the next time, thanks for watching. And again, if I get the information, they'll be right after this, will be the addendum. If not, description below. Have a good one. Quick addendum. I did get a response back, and yes, if he went above about 50% on this knob, the trains would derail. So, it's not just the fact it's got a new motor in the one and fixed drive stuff on the other drivetrain. It's that this literally puts out too much speed or power for the train. So like I said, if this was a straight track and it was like a mile long, it'd be great, but it's 4 feet. So, and I did test putting this piece back on, and it won't switch into the other, it won't reverse. So I don't know if this is something you pop on and off to make it just go straight only, or why this is here, but it interferes with both trains, preventing it from reversing. I did that while I was waiting for the response. Maybe this is the wrong piece, I don't know. But I'm going to leave it off, so that way it actually goes backwards and forwards like it's supposed to. And as long as you run this at 50-40% speed, because there is little serrations, you can see them right there. It's like a real train knob if you do train setups. It'll work fine. Now, maybe you want to launch the train and you take your track and you set it up at an angle and shoot it off the end. You might want to go full speed, but having a train launcher probably isn't really good for the train car. So, other than that, those two are done. Now it's on to the next video.